Hi everyone, welcome back to my YouTube channel. This is Preeti from Sri Venkateswara College of Engineering, studying in ECE department. Today I am going to discuss one of the topic that comes under digital communication, and the subject code is BEC 503. And the topic I am going to discuss is modulation techniques in digital TV broadcasting. First, we have to know what is digital TV broadcasting. Introduction to digital TV broadcasting. Digital TV broadcasting has revolutionized the way we consume television content. It enhances pictures and sound quality compared to analog broadcast. Understanding modulation techniques is key to grasping how digital signals are transmitted. What is modulation? Modulation is the process of varying a carrier signal to transmit information. It allows digital data to be effectively transmitted over various media. Different modulation techniques can affect the quality and reliability of the signal. Then, importance of modulation in digital TV. Modulation determines how well a digital TV signal can be transmitted over distances. It impacts the reliances of the signal against interference and noise. The choice of modulation can affect the overall bandwidth efficiency. The figure shows the message signals and the modulated signals and the carrier signal. Overview of common modulation techniques. Several modulation techniques are used in digital TV broadcasting, including QAM and OFDM. Each technique has its own strength and weakness. Understanding these techniques is crucial for optimizing transmission. QAM is quadrature amplitude modulation. Digital modulation techniques. Quadrature amplitude modulation QAM combines amplitude and phase modulation to transmit data. It is widely used in cable TV and satellite broadcasting. Higher order of QAM allows for more data transmission but can be more susceptible to noise. Then 16 QAM versus 64 QAM. 16 QAM transmits 4 bits per symbol, while 64 quadrature amplitude modulation transmits 6 bits per symbol. Higher order QAM schemes like 64 QAM provide higher data rates. However, they require a stronger signal and can be less reliable in poor conditions. Then orthogonal frequency division multiplexing, that is OFDM. Orthogonal frequency division multiplexing divides signal into multiple closely spaced subcarriers to transmit data. It is highly effective in combining multipath interference. OFDM is the modulation scheme used in DVB-T and DVB-T2 standards. Then advantages of OFDM. OFDM provides high spectral efficiency and can support high data rates. It is robust against frequency, selective fading, and interference. The technique allows for the use of advanced error correction methods. Then disadvantages of OFDM, that is orthogonal frequency division multiplexing system, can be sensitive to synchronization issues. It requires complex implementation and process power. The high peak to average power ratio can lead to efficiency losses in transmission. Advantages: simple implementation by means of FFT, high spectral efficiency considering number of subcarriers. Anti-ICI and ISI makes OFDM receiver less complex as almost no equalizer is needed. The disadvantage is requires high linearly amplifiers, sensitive to Doppler effect. Guard time introduces overhead. Then vestigial sideband modulation VSB. VSB is used primarily in ATSC, Advanced Television System Committee standards. It effectively reduces the bandwidth of the transmitted signal. VSB is designed to be resilient against signal degradation. Then comparison of QAM, OFDM and VSB. QAM is effective for high bandwidth applications but is sensitive to noise. OFDM excels in multi-path environment but requires more complexity. VSP balances bandwidth efficiency and signal reliance for terrestrial broadcasts. Then the diagram shows the amplitude modulation, frequency modulation, and phase modulation. In the amplitude modulation, the only the amplitude of the wave varies where the frequency and phase of the wave remains same. In frequency modulation, only the frequency of the wave changes and the amplitude and the phase remains same. In phase modulation, the amplitude and frequency remains constant, only the phase of the signal changes. Then role of error correction in modulation. Error correction techniques enhance the reliability of digital TV signals. They help recover lost data due to interference or signal degradation. Common methods include real Solomon and convolution coding. And future trends in modulation techniques. Emerging technologies are pushing the boundaries of modulation efficiency. Techniques such as a 256 quadrature amplitude modulation and higher order OFDM are being explored. The evolution of modulation techniques aims to support 4K and 8K broadcasting. Then impact of modulation and receiver design. Modulation techniques dictate the complexity of the receiver design. A robust receiver is needed to decode higher order modulation schemes. The effectiveness of receiver algorithm is crucial for signal fidelity. Then case study of DVB-T2 implementation. DVB-T2 utilizes OFDM and advanced error correction for terrestrial broadcast. It offers improved capacity and coverage over its predecessor DVB-T. The implementation has resulted in better quality and more channels for viewers than global modulation standards. Different regions adopt various digital TV standards impacting modulation choices. ATSE in North America, DVB in Europe, and ISDB in Japan are notable examples. Understanding these standards is vital for international broadcasting strategies. Then, challenges in modulation techniques. Signal interference and environmental factors present ongoing challenges. The trade off between data rate and signal robustness must be managed. Continuous research is essential to develop next generation modulation techniques. The role of software defined radio SDR. SDR technology allows for flexibility in modulation schemes. It can adapt to changing transmission conditions and standards. SDR is driving innovations in digital broadcasting and signal processing, one device for many standards. In conclusion, the future of digital TV modulation. Modulation techniques will continue to evolve with technological advancements. The focus will be on achieving higher efficiency and better quality. Understanding these techniques is crucial for stakeholders in broadcasting industry. That's all. Thank you for your attention. Please like, share and subscribe my video. Thank you.